chapter 11 is here, and the first thing actually is, that's right. First thing is I wanted to show you this challenge that I did not get to last time because it was broken. So here's I was checking Kaiser, by the way. Kaiser's pretty mysterious. I logged into my account and I can't find my name and password going up to the server at all. So I'll see if I can eventually figure out.
What made you check them?
Well, I haven't, no, I wanted to get the shingles vaccine. There's a new shingles vaccine that is supposedly lots better. And I wanted to find out if they had it and whether I could get it. And I couldn't answer that question. But at least I got a look at their login process, and it's actually pretty interesting. But I don't have a result on that yet. Maybe in another class. I logged into Kaiser, and it's not easy. Anyway, but now I want to show you SAML. So not that one, SAML. There, SAML. All right. So this is the thing I tried to show you before. So this page is using SAML. So right now you are not logged in. So the kitten is asleep. And you're at a site called SP, which is the service provider. And this is the way federated identity management works. When you log in, you go to a different server, which in my case is just one I also set up called IDP, but in the real web, it's mostly other people like Facebook, log in with Facebook, log in with Twitter, then come back. So you log in at some other site and put in your username and password here. And there's only a couple of test accounts in this little thing I made. But you can log in. And when you log in, it gives you an identification token, which you then send back to the service provider, and they now know who you are. You're logged in as user 1. And the way this works, you can see it in Burp. Burp is our friend in this class.
Banks use picture as a validation too. Sometimes banks have you choose a picture, that's your picture as validation.
Yes, and all that is up to the identity provider. And this is why people don't want to do something like make a game, can code all that. They don't need to handle passwords or anything. They just let you log into Facebook. And then they just believe the Facebook API that gives them a token, and they just believe whatever Facebook says. And that way, Facebook can have two-factor and fingerprints and whatever, and it's not their problem. After I've logged in, I come to this service provider. And now, when I try to go back to the service provider page after logging in, it recognizes me because I have this SAML response. And this horrible, huge thing is a giant blob of base64 encoded text, and that is the token. And SAML Raider lets you see that token. SAML Raider unpacks it, and
nice background.
And it still never gets very easy to see, but here's what it looks like. You have a bunch of XML here, and let me try and make it a little cut off that way. You've got a signature, you've got a key, a certificate, and then here you have another signature, and those signatures prove that you are who you say you are if submitted to some kind of mathematical test. And here's what it proves. It proves that I'm in fact user 1 with that email address and that name and first name and that last name. So now the other provider can tell who I am because of those signatures. And of course, the weakness in this is that the service provider is probably not as professional as the identity provider, and they might not really bother to verify all this properly, and they frequently don't. And so if you use SAML Raider in the project, you'll find you can just turn your name to administrator, remove the signature, and it will fall for that. And that's if you just change the name here. Now you can't change anything in this because this is history. It occurs to me this is the right class, so I should probably go through it a little bit more. So to really do it, you have to intercept it. Turn on intercept. First let's log out. So what you do is log in, get ready to log in, user 1 and PWD is the credentials. Now turn on intercept. Now log in. Now it has intercepted that request here, and the first request is not interesting, so I forward it. This is the one where SAML Raider comes up. This is the one that contains the SAML token, so I can modify this one. So if I change user 1 to admin, and then quit intercepting, this is like taking an ID card like a driver's license, just whiting out the name, putting another name on it, and see if they'll fall for that. And they won't fall for that. It gives you an unhandled exception saying validation failed. So it's not that stupid. Like, it notices that the picture isn't right. So that didn't work, so you gotta try again. So let's log out, log in again as user 1. All right, and intercept this one. And we can try a different test. There are like 8 different attacks in SAML Raider. So I forward this one. This one has the SAML. I could remove the signature. and then stop intercepting and see what happens. And what happens is I'm logged in as user 1. So this is called a fail open vulnerability. This happens pretty often. They have some kind of test. If some mathematical computation on the signature is what I expected it to be, it's okay. But if there is no signature at all, it gets confused and passes the test instead of failing the test because the developer forgot to really think of no signature. So there's some kind of comparison that fails because an empty thing is compared to a thing that has a value. This happens pretty often. So it accepted me with no signature at all. So that means if it'll fall for that, then I can be anybody I want as long as I remove the signature. So user 1, password, and intercept that. Log in, forward this one to get to the one that has the token, remove the signature, and now that I've removed the signature, I can just change the name to admin and quit intercepting, and now I'm admin. So, this is the general case, and SAML ready to let you try a whole bunch of attacks. And it was in the textbook, I think, in an earlier chapter, about 5 years ago, 11 of the 14 frameworks. Oh, it's in more detail in the mobile device class. There were 14 common frameworks used for SAML, and 11 of them were vulnerable to tricks like this, until about 5 years ago when a paper came out pointing this out, and then they upgraded them. So now, if you actually obey all the rules and correctly implement everything, without making any mistakes or shortcuts, you know how common that is, but anyway, if you do that now, you won't fall for any of this. Now the only sites that are going to fall for this are ones that are using out-of-date stuff or ones that don't have it properly configured, which is quite common, of course. Very often people try to install it, it doesn't work, they change this, they change that, they comment things out, turn off unnecessary irritating security checks that make the app fail, and then go on. There was an Android app I found like this where it did not check the certificate. It accepted an invalid certificate. So I sent a vulnerability report to the developer. I said, dude, your app doesn't verify the certificate. I can use a fake certificate like from Burp, and it totally falls for it. And he said, yeah, that's right. I just added that latest version. Do you like it? And I'm like, dude. And he's like, yeah, you know why I did that? People were getting these error messages. It was irritating them. Then they couldn't use the app. So I found, hey, you can turn off this validation stuff. It works great now. I think it's swell. He said, if you really, I said, dude, he said, well, if you don't like it, use these advanced settings. You'll see this button says, don't change anything in here, or you'll break the app. If you go in there, you can turn it back on. But what would you want to do that for? And I'm like, dude. Anyway,
where is this guy located?
What's that?
Where is he located?
I don't remember. Anyway, I wrote it up, and he said he was going to fax it. I tried to say, dude, you can't just turn off the fundamental security feature and not even tell anybody. Leave it off by default. And be happy, this is wrong. And he said, well, I'll fix it. But then he didn't fix it. Anyway, but informing people of vulnerabilities tends to just get you a punch in the face. So this one's fun too. This one here I just learned about from a training product. And let me show you that one. If I can use Chrome for this. If I go to the attack server, we've looked at some of these PHP vulnerabilities before, I think. Used some of them in the projects, and I added a new one at the end because I learned about this one called Preg Replace. So here's a form, and I needed a form that would replace something, so I decided I'd go with the Hillary Clinton fax form. Remember she had this thing where we had faxed something, and people said, hey, we can't fax this, it says top secret on it. And she said, get scissors and cut off the top inch so it doesn't say top secret, and then fax it. That's why other people were getting pretty sore about that. She totally did that, there's an email trail for it. So that's what this does. If you put in Fred, and post,
that's legal, right? Just cut
it puts Fred on the message. Okay, it puts Fred up here. Okay, so let's clean the board. There's down at the bottom. There's clear the board. Okay, board emptied. Okay. So if you put in secret Fred, then it removes the word secret, sanitizing it. There, you get only Fred. And there was some kind of error message, but I don't care about that. So now this turns out it does it with this line of code. And this is a function that is so dangerous, this was actually removed in the next version of PHP because this turned out to be a nightmare. There's this thing called preg replace, regular expression replace, where you put in a regular expression of this, the usual kind. I've got secret and then arbitrary characters, and the stuff in parentheses is interpreted as item number 1, and I just keep item number 1 and throw away secret. That's what this regular expression does. But there are modifiers here. You remember your regular expression from Unix, you put a G to do all global replacement to change them all? There's this option called E, which executes this as code. And I don't know why they added that, There were quite a few things in Unix that will do this, like there's a netcat option that executes things as code, and they pretty much had to take them all out as time went on because they're just asking for it. So if the developer did make the mistake of using an E there, or allow you to inject that character so you can change it to an E, then, of course, you can put in active code, and here's the way the code looks that does it. Secret, and you just have dollars and curly braces to turn on the feature, and this will execute ls. You got command injection here. So it's the dollars curly braces system, and then ls in there, and now when you post it, you get ls down here. So, of course, you can put in any Unix commands you want there, and off you go. So this is yet another command injection. Anyway, and here's one of the many blogs and everything about it. This was found a few years ago and removed in PHP 7. So hopefully, and yeah, I found if you use cloud servers and use PHP 5, they will really, it'll bug you, sort of like Microsoft bugs you if you don't update your Windows 10. They keep saying, mine actually started charging extra dollars per month to keep using PHP 5. To try to make you move to PHP 7. Because there's a lot of things wrong with PHP 5. Anyway, so we're down to logic flaws. This is a category of vulnerability that doesn't have a simple, obvious signature, like SQL injection or something. It's just, and this is the most difficult thing in all forms of software, is not, you can fix like things like that, where there's some dangerous function and they replace it, you can update your libraries, but there's always, if you just didn't think this all through, things will happen. And the problem is, even if you're really smart, your company has many developers and many generations, and people come in and add things, and they don't even tell you. Yeah. So pretty soon you've got strange paths through your company and your apps that lead to undesirable things, and it's hard to catch them. So this, I don't have the multiple choice games today because this isn't that kind of stuff. These are real case histories from the book. So, all right. So this one here is good, asking the Oracle. The design flaw here is the remember me function set a permanent cookie. Now, we talked about this before. The right way to do that is to generate a random number, if you can find one somewhere, but somehow generate whatever passes in your framework for whatever is currently accepted as a close enough approximation to a random number. May God have mercy on you. And then send that to the user. And then store it somewhere in a database on the server. That random number means this guy. That's cool. There should be no meaning in that random number. But a lot of people find that to be too much hassle, so they instead take your real username or something and encrypt it somehow, send it to you. And so that's what these guys did. They took your name, user ID, and like a timestamp and encrypted it and sent it down to you. And the problem is they also, why did I had an encryption routine? They used the same encryption routine to encrypt something less important. They encrypted your screen name and stored it in encrypted form, and that's what they thought would be okay. But the problem is, of course, the user can't control your screen name. And the app decrypts the screen name cookie to display it on the screen. So you have access to a decryption function. You can change the input. So all you have to do is take the remember me cookie and change it into your screen name, and then run it through the app and it will decrypt it. Then you can see how it's built. And now that you can see how it's built, you can craft one that makes you someone else, like the administrator, run it through the function to encrypt it, and have the remember me cookie to be somebody else. And that's what they call the Oracle. You have this encryption routine, which would actually be kind of okay if it used the right kind of encryption and the key was not available to you, which it probably didn't. But you don't even need to crack the encryption if they let you find the encryption routine and just use it, which is what they did. So, all right. And by the way, he says the encryption was triple DES and unbreakable, but I don't think so. He just didn't try hard enough, is my guess, because triple DES is private key encryption, and the key has to be somewhere. And if the app decrypts it, the key is in the app. That's what I did with all the Android apps. The only thing that would be unbreakable would be public key encryption, where you only have one key and you need the other one that is not on the thing. But anyway, that's the game. Look for things that are encrypted and not hashed, and then wander around and see if you can substitute other encrypted values you find. They got on Facebook this a while ago. They found that the password reset token that was emailed to you was in fact also used somewhere else on the thing. So like it's a tag. So they're able to find something on your page and create that email. So they have the password reset token. So, just flip around encrypted values and see if you're lucky. If you take something else, like a time of day or something and feed it in as the encrypted token, it will decrypt, and it might turn into an error message. It will tell you, oh, username okay, but the next field looks wrong. You'll get a clue that it wasn't just meaningless gibberish. It turned into something that the app could understand to some extent, and then you know you're on the right track. That's why informative error messages are always a problem. Because if it just says, no good, try again, that's fine. But if it gives you any further information, you can often use that as a clue to tell when you're making progress. So here's another one. There's a password change function, the usual kind. So if you click password change while you're logged in, it will ask you for your username, existing password, new password, and confirm new password, and send all that to the server and change your password. And that's normal. The problem is the administrator also needs to be able to change your password. And the administrator's form just asked you for the new password, but of course not for the existing one. And they chose to reuse the same code for the administrator's password change. And instead of having the administrator have to put in something like the administrator password to do this, or the administrator's authentication token, they just made it so it notices if the request comes in with no old password, that must be the administrator. So all you have to do is go in burp and remove the old password from your request, and it will let you change anybody's password because it thinks you're the administrator. And there are a lot of things like this. You have different words for it. One common thing about this is unsecured direct object access. You let someone have administrator privileges without really providing an administrator identity token to prove they're the administrator. You settled for some indirect clue of them being the administrator, which is possible to forge. And really, that's kind of how they all work. You settle for some kind of foolishness instead of really making sure that you know who somebody is before you let them do a high privilege thing. So that's the game, of course. And this really happened to AOL. All these really happened to people. So like I say, try deleting parameters one by one, delete them, totally remove the parameter and see what happens. Remember like before how you just add like admin equals true, test equals true, debug equals true to things and see what happens. You should also try removing things and see what happens. Sometimes fun things will happen. Then here's one we talked about in more general terms before in more detail. So you have your shopping. Browse the product, put something in the basket, return to the basket, finalize the order, enter credit card number, and then enter delivery information, and then hit buy, and you're all done. Now the problem is, what if you skip over some of these steps? The developer assumed that you would just go through them in order, but of course, if you're in burp and you save all the requests, you can just go replay this one, then replay that one, skip over, and so here's what you do. You proceed directly from step 2 to step 4, and you get the product without paying for it, because it assumes you must have already put in the payment information. So in general, just try skipping stages, try repeating a stage more than once, try doing later stages first, earlier stages last, and all these things, try to find the assumptions they're making and violate them.
Amazon has a nice fun thing. I won't mention who, but someone bought something at Amazon, didn't get it, and realized one of the digits on the credit card was wrong.
Well, that's one of their statements on the credit card was wrong. Yeah,
Still went through.
I'm surprised.
It acted like it went through.
Oh, I'm surprised it would go through because there's a simple test they'll implement for that.
I don't know what to tell you.
Okay, that's interesting. I do know there are a lot of these things that happen only occasionally. Like I've had students come to me and tell me I opened up like Gmail on my phone and it was somebody else's Gmail, and you'll find a lot of cases like that where these things happen rarely. And so there certainly are cases where that kind of thing happens. I know there was one I heard about 5 years ago. Google decided to offer free VPN to everybody, and then they decided to offer free wireless internet to everybody, make it faster. And they offered like a proxy service like Cloudflare to everybody. And they rolled it out in like a beta test, and a bunch of people found that there were sites, because they have to rewrite the page to do that. They make a copy of the page on their server, then they serve it up to you, and it turned out that there were people who were using something non-standard as the identity token, so that when they made the copy and served it up, they didn't have the right token to tell who it was, so they were handing over other people's email to you, not the right person's email. And so they took it down and it vanished and it never came back. Because Cloudflare had the same problem. Cloudflare had a similar issue about 6 months ago where they were rewriting some stuff like to hide the email addresses on a page, and if you had like JavaScript with syntax errors, their rewriting would change it. So there were a few cases in which you'd see somebody else's stuff, and they were all freaked out and they explained how they fixed it. But You know, if you handle somebody else's page, you now have a responsibility for what happens, and you can't anticipate all the little things that can go wrong. Anyway, so here's this insurance one. So you're going to buy insurance, and so first there's a lot of stages. First you fill out all this information about you and your income and your risk, and then the app does a bunch of calculation to determine if you have numbers. Then you supply health information, jobs, travel, and all this jazz, and then it's sent to an underwriter, who is a human that examines your thing to decide how much they should charge you for insurance. And the underwriter uses the same web app. They log in with some other account, and they then approve it or deny it. And so there's a shared component, and of course, they keep bouncing the data off the user, step after step here. So they parse all this data into name value pairs. You have this state information that's flying around like that big SAML assertion we saw, with all this data changing. And of course, they assume that every stage has the data that comes from the previous form and it hasn't been altered. And they did not use something safe like an ASP.NET signed encrypted token that's hard to alter. So if the user changes the parameters, the user can do rotten stuff, like they can add the validation parameters, so it appears to have been validated by the auditor when it hasn't. And he was also able to inject XSS that leaked information out about other people as the thing goes through. They're able to change the price, change the monthly premium, turn on the approval, which wasn't approved, and all that jazz, because they kept bouncing this blob of data off the user and assuming that only the thing the developer expected to change was changing at each step, and trusting what came back instead of verifying it, which would be a lot of extra work. So that's the game. You take parameters from one stage, add them to a request to another, and see if it will fall for that. If the and change parameters around. All right, so here's a bank. This one, I remember when I first read this one, I had to go through it a few times to get it straight. So the thing here is you can register for online banking, but if you do, you can't do it online. You register online, and then for security, they have to send you a real piece of mail with like a pin in it before you can go. And I think this is true of credit card numbers and stuff. They mail you a credit card, then you have to call a phone number. So it's supposed to be pretty secure. And it actually is pretty secure as long as nobody would add anything to this app. But the problem is, so the original people who register an account have to actually really get the mail and get the pin and all that jazz, and that's fine. The problem is, what about existing people? There's a data structure held in memory while you're logged in and stored otherwise. It's got your, date of birth, home address, customer number, and everything. There's a database. Okay, so when you create a new account, it creates this record, and you can't use it until you log in. The problem is, after you've done that and you log in with an existing account, you're still using the same database. And even though you're using a database with the account you created, new people are coming in registering new accounts that goes in the same database. So it turns out, if you log in interactively, you can then access the create account screen while you're logged in. And what this will do is mix the two together. So if you log in with valid credentials, now that you're logged in, you go to the registration function and submit a different customer's personal information, and they will overwrite their object with a new object. They create a new object, and you will end up having access to the other person's account. By mixing creation and logging into an existing account, you're able to confuse it. And this is tough, because people are told to reuse code for efficiency and consistency, and so it'll survive through the updates, and so it's hard to think of all the data flows. All right, so that's the game. Same database object written two ways. The main function lets you write after strict authentication, but the registration function writes without authentication because they think you're not able to use it until they mail the mail to your home. And they didn't think to check.
Which bank did you try this game?
A real bank, but he didn't tell us. Obviously, they have a non-disclosure agreement. Customers wouldn't thank him for telling us which bank this was. But I know from what I've done with banks, they're no better than you think they'd be, and a lot less interested in fixing anything. They mostly just tell you to shut up and go away. Anyway, so then there's a business limit. I remember one of the most famous hacks in history was a guy that did this, a Belgian guy, managed to lose $5 billion from like the Belgian National Bank, and he was only supposed to be allowed to invest $100,000, but he figured out how to manipulate the papers inside the company so he would have bypassed the limits. And you can do it online. So this guy had an application that prevents users from doing a transfer over $10,000 without getting manager's approval. So the code does this. If the amount is less than $10,000, then it does not require approval. If this fails, then it returns true and says this does require approval. So all you have to do is transfer a negative amount and then flip the account numbers around. The money will go the other way, and you can make it as big as you want because they didn't think of that. So you can move as much as you want as long as you reverse the source and destination addresses, and it never has to have approval. This tends to happen. The one I thought he was going to say, which didn't do here, which also works, is to make the negative number so big that it wraps around and turns into a positive number. That's a common trick because computer numbers only have so many decimal places, and if you take them too far, they wrap around. But anyway, all right.
What did he do after, like, they catch you doing this glitch?
With what, having done this? Well, of course, you've committed fraud now.
Yeah.
And so you got to run and all that jazz. I mean, it does nothing's going to make any of this legal. But you want to make apps where it's not possible because people will do it from another country where you can't prosecute them. Anyway, so here's another one. There's other kind of numeric limits like this where people can only order so many products and so on. And in general, try negative values at each step in addition to large values. People may forget this. Here's another one I've seen a million times. Like I remember one time Microsoft was giving a free thumb drive, and there was a trick to get as many as you want. And within like 24 hours, people were getting 1,000 each, and Microsoft wised up and refused to ship them if they're all going to the same address or something. But this happens a lot. So here's a discount where if you buy like a bunch of things together, you get a big discount. If you buy only one product, you don't get a discount, right? But there was a simple solution here. All you had to do was fill your shopping cart with all the junk, and then remove it all from your shopping cart except the one, and forget to lower the discount. So you would end up with the high discount even while you're only buying one product.
Oh.
And that's the one I know. There's always a lot of tricks. I mean, there are very simple tricks of Microsoft attacks where all you have to do is see them coming from a different IP address, like through Tor, and you can keep getting another free whatever. You know, people, that's why if you do any kind of online poll, like vote whether you approve of Trump or not, you can just go through Tor and vote 1,000,000 times. It won't know who you are. Use privacy mode. It won't remember you. What can they do? They can't
fill out a survey, get a prize.
Yeah, you didn't log in. All they can use is your IP address. You change your IP address, you can vote as much as you can. So that's why when they had Time Man of the Year, I think 4chan made some Milo Yiannopoulos.
Marble Cake, also the game. But they spelled out like Moot and Kanye West and then Jesus Christ.
Yeah. So you can just totally manipulate these things. Make as many votes as you want with the script. But it's very hard to stop. All right, and here's one with escaping. So these guys decided to take user-controlled input in an operating system command like the ping form you did back in Project 1. Now this is something you generally avoid, but you will see in the book they say if you've got to do this, then be sure to remove all the special characters. So they did that. All these special characters, they would put a backslash in front of it automatically so they wouldn't take effect. But they forgot to backslash.
Oh.
So if you enter foo backslash semicolon ls, it will add a backslash to the semicolon, but not to the backslash. So this will cause the backslash not to have an effect, and the semicolon will work. So, you know, that is the fundamental problem. If you do decide to stop all the dangerous characters, you can't miss any of them, or it doesn't work. So anyway, that's the game. Now you can do injection by injecting a backslash, which will be canceled by the other backslashes they add. All right, so here's another one. There's another common filter. You change quotes to double quotes. In SQL injection, that is what you are supposed to do. A double quote in a literal in SQL is interpreted as a single quote. That's how you're supposed to put in things like apostrophes and names that contain apostrophes. And as we've seen, it can lead to trouble in second-order SQL injection, but it can also fail here because you have another control. Length is limited to a certain amount. And the problem is, if you have two controls, they have to be applied in some order. So if you first add a quote and then truncate it to 128 characters, then obviously all you have to do is inject 127 characters and a quote. It'll add the quote and then cut it off again. So now the idea, it works of course under normal conditions. If I add this, admin apostrophe dash dash, which would turn me into the administrator, then it turns into admin quote quote dash dash, and that tries to find the literal name admin quote dash dash. It does not misunderstand it and let me in as the administrator. But if I put in 127 A's followed by a single quotation mark, then it cuts off the other quotation mark that was added, and I now have a SQL syntax error. So it means there are injections I can do that will work. So what you do is you put this in a password of that, and now you have this red stuff is all the username, or 1 equals 1. So by using both the username and the password as injections, you're able to result in a query that will always be true and let you in as the administrator. So, you know, if you have any of these filtering things, you just are a challenge to the attacker to be smart enough to overcome your filtering. So if you want to detect this, just inject long strings of apostrophes and look for syntax errors. If their filtering works correctly, you'll never have syntax errors, but if it somehow cuts one of them off, you'll end up with the wrong number of apostrophes and CS syntax. And here's one it's in the CISSP class. They call this inference attacks. If you have some limited ability to see data, but you are supposedly prevented from seeing the details of the data, you can use a large number of low privilege queries to deduce the high privilege data. This is a general fact. For one thing I've been worried about for a while is that we've run out of social security numbers. And for that matter, credit card numbers. There just aren't enough of them. They're not long enough, especially social.
I said that to you like a couple of years ago. Do we have enough social security numbers? And you're like,
we looked at it because there are really only 9 digits in a social security number, and there's an awful lot of Americans. And not only that, they're not random. The first 3 digits tell you what state you're in or something. So highly populated states like California have actually run out like zip codes, or like prefixes for the phone numbers. So in fact, if you just guess random social security numbers, most of them are valid.
Some of them are dead because they take the paychecks from the dead people and just...
They are. But I mean, it's an issue. Anyway, so what this guy did, they had some kind of archive of information you're supposed to have to pay for, but anybody can search. So all you have to do, and the titles are pretty vague here. They're not giving you much information, but again, all you have to do is do enough queries. They didn't limit how many queries you could do for free. So you have to guess. So he did consulting press release, and found no matches with mergers. Just try random words here. When you get a match, it has the word takeover in it. So keep trying words till you find another word. It has completed in it. Then you can try phrases until you gradually build the article, you know, with enough queries, and you can automate this. Blind SQL injection works the same way. And if there's something good in there like a password, then you can just try stuff like this, and we've done things like this in the project. Password is A, B, BA, so on. Until you find things that contain these small strings, you can gradually build up whatever you need. So that's a simple inference attack. And then there's debug messages. This is quite common, that when people have some kind of problem with the system, they make some kind of error reporting to help them debug the problem, and they don't worry about the details of that. They figure it's only temporary. So here, they got a new buggy app, so it puts out detailed error messages containing everything you might need to debug it, like the token and the user's full name and all that jazz, and all the parameters. This is what I use on my server. Apache Forensic Logging logs the entire contents of every web request, which is helpful for debugging things, but is dangerous, of course, because it has their authentication tokens and everything else. And so that's the game here. Now, the first thought is the user could have just run burp and see all the requests, so it doesn't really matter if you log that, but the problem is you're not putting it in your user account. You're putting it in something that is not session-based, like a temp file that is shared by many people. And so the error condition copies data to the container and then displays the information copied from that container, and that creates a race condition. You write it, then you read it later. But it's an error. There could be another error from another user before you read it. So when you actually read it, you'll see somebody else's error message. And that is what happened. People would occasionally see an error message from another user, and you can exploit it. In that case, to see other people's stuff, but you can do even more. You can just keep reading the container. Just go to the page that displays an error and just run it frequently, and you'll see all the errors from all the users. You'll gradually get a bunch of valid tokens, a bunch of valid usernames, and all that jazz. They're leaking data out, and you can just pull it. So that was the end result of that one. And here's another race condition. You got a multi-stage login, and this is considered high security, multi-factor authentication, and that's fine. The problem is they determined that sometimes people would log in and get access to a different user's account. They couldn't figure out what was causing this. And they finally found out that it sometimes happens when 2 people log in at the same time. So this has a flaw. some part of it did not separate the data. It put something in a static non-session variable like something in the temp folder that was shared between users, then read back an instant later, and if it is changed in that intermediate time, this is the classic race condition. Classic type here, and I just added this to my 127 class. Yeah, I think we got enough time here. I might as well show it to you. This one's good, clean fun. I could learn this. So if you go to 127, this is the one I'm teaching on. It seemed like it belonged here, although I could have put it in this class too, but it's actually pretty easy. So I think I can just do this one live. We've got 15 minutes and we're nearly done with the chapter. Let me bring up Kali. 64-bit, that's fine, it doesn't really matter. Let's find the IP address of my Kali. Okay, ifconfig 253, okay. So I'm going to SSH into it, which is more reliable, and I can make the font bigger, easier, and all that jazz. Okay. So, SSH root at. Did I fill it up? Well, maybe this one is not running SSH. All right. Well, now it should be. And so it is. Okay. All right. So let's see what if I've got a folder. No, I do. Nebula. This is one of the Nebula challenges here, although I think I put it in 127, the one I wrote here. Okay. So, all right, I don't have it here, I'm going to put it here. Let's nano race.c. All right, I'll just follow this project. So first, I'm going to need a low privilege user, so let me just do it. Add user noob. Okay, so let's add user noob. Oh, okay, guess I have done it here. Locate race. Oh, I know where it is. Race is over in the noob account. Okay, so good. So let me, all right. So let me show you this program, race.c, which I think I need to be in the noob account to see it. See, race.c. Let's see, just a moment, I'm losing my mind. Find dot minus name, race star, quotes. There, it's in the neb account. Okay, fine, in the neb folder. I've got this from thing called, all right, so nano race.c, I thought I'd done this one. All right, this is my program of the race condition, which is based on something I found in a online training product. So you add a bunch of C libraries, then you go down here and, okay, this is just like cat. Cat prints out the contents of a file. This is going to print out file if you have access to it, but this is going to run with SUID privileges. So it's going to be owned by root, but run by noob who is not root. And if it was a normal SUID program, it would let noob read files that require root permission. That's what SUID does. But in order to prevent that, it uses the access function. The access function checks to see if you have permission to read a file using your real ID, not your effective ID. So even if you're running an SUID program, it checks your real permissions. So when noob runs an elevated program, access will still say they only have permissions noob has. So this will detect that they're not allowed to read this file. Then I just have a time delay. I count up to 1 million or 100,000 or something just to waste some time. Then I read the file because they passed this test. And the point is, this is the time of check. At this time, I see if they have permission to read the file, but down here is time of use. So when I use the file, it's a little bit of time later. So if I'm able to change the meaning of the file, first to one they have permission to see, and then quickly into the secret one they're not allowed to see, it will let them read it here because it passes that test, but by the time it gets down here, the pointer to the file is pointing to a different file. And when I first heard about these, I thought that sounds really exotic and hard to do, but it turns out not to be that hard to do at all. So, once you get this thing compiled, which I've already done, and I have a secret file, let me just go into noob and show you what happens to noob. So I do a switch user to noob. Now I'm no longer root, so I have a $sign. And now, if I go to the home of noob, here's some files here. All right, so let's remove that flip. I'm going to make that again later. Okay, here's what I have. I have a program called race, which is the compiled program you just saw, and have a file called secret that noob is not allowed to read because it's owned by root, and root can read it, but nobody else has any permission. And I have a file called public that noob created and noob can read. So let's look at public. If I cat public, I can see that, but if I cat secret, I'm not allowed to see it. I get permission denied. If I run race on public, it prints out the public information. And by the way, I didn't point to it, but I made in my program so it prints out the time difference between the time of check and the time of use so you can see. So the time, it's less than 1 millisecond of vulnerability. But if I try to run race to see into the secret file, I'm not allowed, because that access check determines that noob's not allowed, and it does not go in and do the time of use. It skips over and says you don't have access. So the question is, how hard would it be to fool it? And the thing you do is make a link. So if you make a link, this is a link to the public file. Okay, this is a symbolic link, which is what Microsoft calls a shortcut, which is targeting the public file, and the name of the link is flip. So if you do an ls-l, I now have a shortcut named flip, which points to public. So flip is another word for public. So remember, I could do race on public, and that worked. And I can also just use flip, because flip points to public, and it works. I can see inside the file. Now I can change the link. I could try changing that link so it points to secret instead of public. And if I do that, I get an error because the file exists. So what you have to do is you just have to add an F flag, which forces it to move it. Now if I do ls-l, the flip now points to secret. Now if I run race on flip, I'm not allowed because it's pointing to secret. So the thing I want to do is flip back and forth between public secret really fast. And I thought, I have to get it so fast that it has a high chance of flipping during the 1 millisecond of vulnerability. And I thought, that's not likely to work, but it turns out it works pretty well. Here's how I tested the flipping rate. You make a for loop that does it 1,000 times. And count, 1, 2, 3, 3 seconds, I can flip it 1,000 times. So this moves it to secret, moves it to public. That happens, it only takes 3 milliseconds to do that. So if I have a 1 millisecond window of vulnerability and I'm flipping every 3 milliseconds, I'll succeed after about 3 times. So if I do it 50 times, a bunch of them will succeed. So that's all you have to do is get this happening in the background. Now you want it to go on forever, so use while instead of for, and then you put an ampersand at the end, so it will just run in the background and not bother me. So now it's running, flip, 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 flip. And you can tell if you do top, it should be using up something. Yeah, it's up here. Noob is running some process using up 24% of the CPU. So it's flip, 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 flipping. Every couple of milliseconds, it's flipping back there. Okay, so now I want to do a bunch of these. I might be able to just, in fact, I made a loop, but if it's really only like 10 or 20, I probably can just run .race flip and just do it myself. So I do, so let's get rid of this. If I do this there, oops, // race flip. Okay, and I made it. The first one worked, third one failed. I made a loop, but you don't even need to make a loop. I succeeded the first 2 times, then I failed the next 6 times. You know, you'll just succeed some reasonable portion of the time. Something like 1/3 of the time or 1/10 of the time. This will just happen to work and you're in. So that's a race condition. One thing that's a little bit inelegant about this is if you just walk away, your machine is constantly running now. So in a project I said just log out, but when I did this in class, I figured out one thing to do is go top. You can see the process that's using up the CPU is 3786. So you can kill it here. And that should get you back to normal where I'm 96% idle and nothing's happening. Anyway, so that's a race condition. You see, it is far more practical than I at first thought to exploit these. Even a brief period of vulnerability can be exploited because you can use your computer to just move pretty fast and try something a lot of times. So here's some recommendations to avoid these nasty things. Document the design so you can really make a good flow chart. This happens, then this happens, so somebody can think about the logic of all the steps it passes through. This good practice for this is the old game like Zork, where you wander around north, north, south, south. You end up having to make a map. Comment everything. You should know what each component is doing, what the inputs are, what the output are, so someone can consider what assumptions are made about the input and output. Consider all these things and think about the circumstances that violate your assumptions. It is, well, I've done some coding. I used to do a lot more than I do now. It is just really hard to think of everything, you know. It's always very tempting to, oh, I don't care about that. I'll just only do the case that gets me to my goal today and not worry about what if this is negative, what if this is 0, what if that's equal to that, what if this other thing hasn't happened yet. You know, you have to really think of all those things at every stage or you'll be sorry. So think about how it handles unexpected behavior and look for dependencies, look for how one component uses data it got somewhere else and depends on what some other component did. One thing that I think helps here is what Netflix does. They have a thing called Chaos Monkey that randomly breaks everything on the network. It randomly takes down interfaces, disconnects servers, stops processes, creates errors deliberately, because they say everybody has to get in the habit of coding to think about what could go wrong. So we're going to have this thing running all the time, breaking everything at random. So you just
hire someone to do that for fun. That'd be enjoyable for cheap.
You could. Those are internal pen testers. There are real jobs that do that, and they have those too. But they also have this thing: get over planning for reliability, plan for unreliability, and get ready. Whatever you're doing, what happens when it fails? Where's the backup?
Power outage.
They got it. I think it also turns things off randomly. You plan for all these things, and you might as well get used to it because they want it to stay up. So that means every single bit of it has to be ready for any other bit to fail. And that's how you do it. That's why they said they wouldn't hire our students. They didn't want interns, they didn't want graduates. They said, we don't want to have anybody here that hasn't spent 5 years of real coding somewhere in the real world, because that is the only training that gets you ready for doing this. Where you're over pretending that things work like they do in the books, and you're down to planning for the real world where everything has everything wrong with it. So anyway, that's the game, and I guess that's it.
Actually, there is a
fitting in an hour. Yeah,
a side note since you said flaw. I found a flaw with Hyper-V for like if I try to add another SCSI device under Windows 10 Educational, and it won't let me. I can't back up the server. There's a flaw.
I'm not surprised, especially on Windows 10. Windows 10.
No, I was doing Hyper-V.
I know,
but I was trying to add a second hard drive, and it said, "Sorry, you can't do that." Yeah.
Well, I know.
I have 2 hard drives: the boot virtual hard drive and the second hard drive to back up my computer. Right.
Well, you know, I don't think Microsoft really supports Hyper-V running on Windows 10 much. They think you're going to run it on the server. And also, Windows 10 especially is complete garbage. I mean, they keep changing it with every update, ramming it down your throat. The updates are terrible. So it's just amazing. I mean, like I was talking last week, the current recommendation from Woody Leonard is you should roll all your Windows machines back to last November and block all the updates. Because every update since the start of this year.
Build number for that?
Have what? I don't know.
You have to put a build number. The build number is what matters.
Yeah, I know.
It's now 1709 is the current build or something like that.
Right. See, the updates, the Spectre updates that they put on to block Spectre and Meltdown lower the security terribly. So you have to roll them all back. And Microsoft is still putting patches on the patches and making it worse.
Well, there's another way to kill your virtual server. Yeah. All you have to do is mount the virtual hard drive one time with the mount, right-click, mount virtual drive. Then server will no longer recognize it. It will die. That's all you have to do to kill the virtual OS.
I'm not too surprised.
Yeah, I've done it. I killed my server just by mounting it in Windows 10.
Yeah.
It no longer recognizes it because the checksum no longer works.
I know. It seems like Microsoft is not testing their stuff for the last 6 months. The wheels have fallen off the bus at Microsoft.
Yeah, but it'd be fun to do at B-sides, have someone do, present here's Windows 10, here's Hyper-V, let's kill this virtual machine. All you have to do is mount the virtual hard drive, that server, Windows 10, try to boot it again in Hyper-V, it will no longer boot because the checksum has failed.
Yeah, well.
Yeah, that's how you do it. I found it.
Yeah, well. There might be something there, but you have to do a lot more work. You have to figure out how to make it do something interesting.
No, I killed it. Server no longer boots.
Or actually, you found a
That is,
bug.
yes. What are you talking about? Server no longer boots.
You've got a bug, but it's not a chalk unless you.
I know I'm making a
prove them.
joke,
Yeah.
but it's a
No, that's right.
possibility.
No, it's just.
I was going to clone it. I was going to clone the virtual hard drive outside of the Hyper-V as a virtual drive. Clone one virtual drive into another virtual drive, imaging it. But I couldn't do it. If I mount it, you will kill it.
Well, right now it's a bug, and it may not have any security vulnerabilities. Anyway, I'm going to go up to the lab if anybody's going to work here. I'll be
Killing something is half the fun.
That's a start.